This is a re-upload of the video I had on coding a selection. Initial video was slightly erroneous. This one is corrected. Here it's a perfect illustration of the power of the strategy of divide and conquer, where generalizing a particular solution from a special case actually only results in improvement of the solution, and also an illustration of the power of inductive or generalized reasoning. Now we know in the binary encoding of a number, if you wish to encode a number less than m, we compare it with values m by 2, m by 4, m by 8 and so on. Now the instinctive thought that would have occurred to almost everybody is it possible to say cut it down by half by comparing it with square root of m? Answer is yes, it can. If we express is as m is equal to m1 square plus m naught, and the number n itself as n1 square plus n naught. Then two possibilities arise. Either n1 is less than floor of m1 by 2, which will correspond to the case 0. But if it is greater than or equal to m1 by 2, floor of m1 by 2, if n1 greater than or equal to floor of m1 by 2, then floor of m1 by 2 can always be subtracted from n1. Now n1 itself is of the form n1 is equal to floor of m1 by 2 plus x. Since we know that n1 plus 1, in general n plus 1 the whole square minus n square is equal to 2n plus 1. When we take away m1 by 2 from n1, the difference will be 2 times floor of m1 by 2 plus x minus 2 times floor of m1 by 2. So in general it is possible either if n0 is greater than 2 times floor of m1 by 2, then 2 times floor of n1 by 2 can be subtracted from n0. N0 may not be equal to, in other words, up to m1 can be subtracted from n0. So, so only three possibilities arise: 0, 1 and 2. This corresponds to the case when n1 less than floor of m1 by 2. This corresponds to the case when n1 greater than or equal to floor of m1 by 2, comma n0 less than m1, and this one corresponds to the case when n greater than floor of m1 by 2, comma n0 greater than or equal to m1. So this is a case. Now this can be improved by expressing it as a cube or taking the cube root. If m is itself expressed as m1 m2 cube plus m1 square plus n0, likewise the value to be coded is also expressed as n2 cube plus n1 square plus n0. Similarly, now if we take away, if we code n2 is less than floor of m2 by 2 will correspond to the case 0. When n2 is greater than or equal to floor of m2 by 2, then we know that n plus 1 or n plus x the whole cube is equal to minus n cube is equal to 3nx times n plus x. So the difference will be 3 times, if m2 by 2 is subtracted from n2, then flow times 3 to m by 2 x, and assuming n2 is equal to floor of m2 by 2 plus x, then the difference will be plus x. So then, in other words, 3 times floor of m2 by 2 the whole square times x plus 3 times floor of m2 by 2 x square, taking x equal to 1. A bare minimum of 3 times floor of m2 by 2 the whole square can be subtracted. Can be subtracted from m1 square plus m0. In addition, we can see that 3 times m2 times m2 plus 1 must be equal to m1 square plus m0. In other words, 3 times m2 square plus 3 times m2 must be equal to m0. This can be written as root 3 m2 the whole square plus 3 m2. So must be equal to m0 plus m1 square must be equal to m1 square plus m0, which gives us m1 is equal to root 3 times m2 and m0 must be equal to 3 times m2. The reasoning we applied for the first case initially when we took the square root or square can now be applied here. So root 3 m2 by 2 can be subtracted from n1. In other words, m1 by 2 can be subtracted from n1. And the same, in which case 2 times m1 by 2 or m1 can be subtracted from n0. The same reasoning can be applied here. m1 is equal to root 3 of m2 and m0 equal to 3 times m2. So this is how we can do that. So in general, here what will happen is, for the case when in all there will be only 4 possibilities, whereas m itself will decrease, will become m2 by 2 the whole cube, m1 by 2 the whole cube nearly equal to m by 8, but in all there will be only 4 possibilities. So the number of bits here, it will reduce by 3 bits, but this will increase by 2 bits only. Code will increase. The information to be coded is decreased by 3 bits, but code increases only by 2 bits, and the encoding is lossless, close to lossless. So now, so in general we will get the following ratio. So initially it will be decreased by 4 but increased by base of numeration is 3. Then decreases by 8 and increases by base of numeration is 4. Then the base of numeration will be 5. Base of numeration, just by increasing the base of numeration, so we can see that there is significant gain, tremendous gain, by, in other words, by just increasing the size of the base by 1, you are cutting down the length of, you're reducing the, gaining significant gain in compression. So the situation, only as the amount of data becomes more and more and more, the situation not only becomes, only seemingly appears to become worse. In reality, the gains that are assured are more and more and more. So it only becomes better and not worse. That is, more amount of information can be compactly and losslessly coded in smaller and smaller amount of data. This is what is actually borne out. It is to be expected that is what we would expect, that there should be significant gain only. That because there is more amount of data which can be compactly coded, therefore the gains assured are more and more and more, not less and less and less. So it only appears to get worse, but in reality it only becomes better and better and better. This is what, so it's a perfect illustration of the strategy of divide and conquer, or